Hello again. This is Math 2232 coming to you from the College of DuPage. The title of this lecture is Heaviside Cover-Up Technique, drawn from the MIT notes. As always, be an attentive learner while watching this video. The cover-up method was introduced by Oliver Heaviside as a fast way to do decomposition into partial fractions. This is an essential step in using the Laplace transform to solve differential equations, and this is more or less Heaviside's original motivation. The cover-up method can be used to make a partial fractions decomposition of a rational function p of x over q of x whenever the denominator can be factored into distinct linear factors. We first show how the method works on a simple example and then show why it works. So in the first example, we're going to decompose x minus 7 over x minus 1 times x plus 2 into partial fractions. Now we know that what we'll want to do is have this expression look like a over x minus 1 plus b over x minus 2. To determine a by the cover-up method, on the left-hand side, we mentally remove or cover up with the finger the factor x minus 1 associated with a and substitute x equal 1 into what's left, and this gives a. So we cover this up, and what's left is x minus 7 over x plus 2, and we're going to substitute x equal 1 into that, which is the root here. So substitute x equal 1, and we're going to get 1 minus 7 over 1 plus 2. That's going to be minus 2, and that's going to be a. So you see, we cover up the factor under a and substitute what will make this denominator 0, substitute a 1, and that will give us what a is. Similarly, b can be found by taking what will make the factor that will be 0 under b. That's the x plus 2. The root of that is x is minus 2. We cover that up. We're left with x minus 1, or excuse me, x minus 7 over x minus 1, and we substitute minus 2 in, and that will tell us x minus 7 over x minus 1. We substitute x equal minus 2 into this way, and we get that b is 3. So our answer is minus 2 over x minus 1 plus 3 over x plus 2. Why does the method work? Well, it's simple. The right way, mathematically, to determine a from equation 1 would be to multiply both sides by x minus 1, giving us this. But now, if we substitute x equal 1, that should say x equal 1, this will become 0, and so a is equal to what's left. The cover-up method, therefore, is just an easy way of doing the calculation without going to the fuss of writing this line. It's unnecessary to write the term containing b, since it will become 0. In general, the denominator of a rational function factors in the product of distinct linear factors like this, and this is the partial fraction decomposition. So if we cover up x minus a sub I, and setting x equal to a sub I, in the rest of the expression, we will get capital A sub I. Let's do another example. We want to decompose this into partial fractions. Well, the first thing you have to do is factor the denominator. So that factors into 1 over x times x squared minus 1, and then this factors again, you factor completely into x minus 1, x plus 1. We get this. And so now what we're going to do is we cover this up, and we substitute 0 in there, and we get minus 1 for this one. We cover up this one, and substitute x equal 1, and that tells me that that is 1/2, and then I cover up this one, I substitute x equal minus 1, and I get that that also is 1/2. And to be honest, the real difficulty in all of the partial fractions methods, the cover-up method being no exception, is factoring the denominator. even the programs which do symbolic integration only factor polynomials who are kind of easy. Therefore, we'll only be integrating rational functions with easily factored denominators. Actually, easy is a relative term. Now, we should note that Heaviside cover-up method can also be used even when the denominator doesn't factor into distinct linear factors. To be sure, this only gives partial results, but these can also be a big help. For example, consider this. Let's just decompose into partial fractions. 5x plus 6 over x squared plus 4, and this is x minus 2. So from our partial fractions theory, we know that this is going to be written as capital A x plus b over x squared plus 4 plus c over x minus 2. And this would end up being 3 equations and 3 unknowns. But since this is a distinct linear factor, we can figure this out by covering up x minus 2 and substituting 2 into here, and we'll find that c in fact does equal 2. Then a and b, which we don't know yet, could be found by the method of undetermined coefficients, solving 2 equations and 2 unknowns. But the work is greatly reduced since we need to solve only 2 simultaneous equations to find a and b and not 3. Following this plan, using c equal 2, we can now put 2 in here and combine the terms, and we get that 5x plus 6 is equal to, that should be an equal to, this times x minus 2 plus 2 times that. Comparing the coefficients of x squared after we multiply through all of this, we find that a is minus 2, and then I substitute in here b is equal to 1. In using 6, this equation, we could have instead compared the coefficients of x, getting 5 equal minus 2a plus b, and provide a valuable check on the correctness of our other values. So you see, Heaviside reduces your effort even here. Still another method would have been to factor the denominator completely into linear factors using complex coefficients, and then use the cover-up method but with complex numbers. That's kind of beyond the scope of what we're doing in this course, but that certainly can be done. The calculations are longer and require skill with complex numbers. Another note that we should make. The cover-up method can also be used if a linear factor is repeated, but here too it gives just partial results. It applies only to the highest power of the linear factor. Once again, we'll illustrate with an example. Here we're going to decompose 1 over x minus 1 whole squared, and then this is x plus 2. So we know from our partial fractions theory that we can write this as a over x minus 1 whole squared plus b over x minus 1 plus c over x minus 2. Now, to find c, we certainly could find c by the cover-up method, but we can also find a, because to find a, cover up x minus 1 whole squared and set x equal to 1. You get a is 1/3. To find c, you cover up x plus 2, set x equal minus 2, and you get c is 1/9. You should check these calculations. This only leaves b, but we know those two, so that means this is a simple linear equation in b, which we can solve, and we will get b is equal to minus 1/9. And you should again check these calculations. B also could have been found otherwise, but we note that we only needed a single linear equation in order to determine B. Simultaneous equations are no longer needed. The fact that the cover-up method works for just the highest power can be seen exactly as before. In the above example, for example, the cover-up method for finding A is just a short way of multiplying all the way through by x minus 1 whole squared and then substituting x equal 1 in the resulting equation. In summary, the Heaviside technique is quite powerful and can save you a lot of time in calculation. Hope you find it useful and accordingly use it well. closing, now more than ever, time is precious. Each day must count. Do the math. It will make you strong. And now, more than ever, take care of yourself and of each other. We're all in this together. God bless you all.